asked to multiply the given radical expressions. For number 1, we have the square root of 21 times the square root of 35. Looking at our notes, the nth root of c times the nth root of d is equal to the nth root of c times d. So to multiply radicals with the same index, we multiply the radicands. So in this case, the square root of 21 times the square root of 35 equals the square root of 21 times 35. Because we need to simplify, we will not determine this product, we'll determine the prime factorization of 21 and 35. Well, 21 is equal to 3 times 7, and 35 is equal to 5 times 7, and therefore this product has a prime factorization of 3 times 5 times 7 times 7. Now that we have the prime factorization, we'll identify the perfect square factors. Every time we have two equal factors, we have a perfect square factor. And therefore 7 times 7 is a perfect square factor, and this will simplify. The square root of 7 times 7, or the square root of 7 squared, simplifies to 1 factor of 7, and therefore this simplifies to 7 square root 15. For number 2, we have 3 square root 15 times negative 4 square root 75. Looking back at our notes, a times the nth root of c times b times the nth root of d equals a times b times the nth root of c times d, which means to find this product, we multiply a and b outside the radical, and then multiply c and d, which are the radicands, under the radical. So for number 2, this product is equal to 3 times negative 4 times the square root of 15 times 75. 3 times negative 4 is equal to negative 12, and now let's determine the prime factorization of 15 and 75. 15 is equal to 3 times 5, 75 is equal to 3 times 25, and 25 is equal to 5 times 5. So the prime factorization of this product is 3 times 3 times 5 times 5 times 5. And now we circle the perfect square factors of the radicand. 3 times 3 is a perfect square, and so is 5 times 5. Simplifying, we have negative 12 times the square root of 3 times 3, or the square root of 3 squared is 1 factor of 3, times the square root of 5 times 5, or the square root of 5 squared is equal to 1 factor of 5, and we still have square root of 5. Negative 12 times 3 times 5 is equal to negative 180. This simplifies to negative 180 square root of 5. And now for number 3, we have the square root of 18 x to the third times the square root of 10x squared. This is equal to the square root of 18 times 10 times x raised to the power of 3 plus 2, which gives us x to the fifth. For the next step, we'll determine the prime factorization of 18 and 10. Well, 18 is equal to 2 times 9, 9 is equal to 3 times 3, 10 is equal to 2 times 5. So for the prime factorization, we have 2 factors of 2, 2 factors of 3, and a factor of 5. X to the fourth is a perfect square factor of x to the fifth. To show this, we'll write x to the fourth as x to the second times x to the second, and we still have times one more factor of x. And now we'll circle the perfect square factors, which are 2 times 2, 3 times 3, and x squared times x squared. So simplifying, the square root of 2 times 2 is equal to 1 factor of 2. The square root of 3 times 3 is equal to 1 factor of 3. The square root of x squared times x squared is equal to 1 factor of x squared. And we're still left with the square root of 5x. So the final result is 6x squared times the square root of 5x. And because the exponent on x is even, no absolute value is required. I hope you found this helpful.